Okay, everyone, so let's get started. I would like to welcome everyone to our mass timber and passive house presentation, an all timber neighborhood in Berlin, presented by Christoph Deimel, who is an architect and teacher at the University of Applied Science in Berlin. Christoph is an expert in sustainable architecture and development and urban planning, and he received his Masters of Architecture focused on urban design from the art school in Berlin, Weißensee. So it's my pleasure to have a colleague of mine and passive house expert here today. And Christoph, it's all yours.
Yeah, so thank you, Andreas, for inviting me to hold this lecture. And I was in New York in 2018 on the Passive House conference, talking about mass timber construction, and we were in the beginning of the building phase of the project Weißensee. So now I can show it. It's finished since springtime last year. I start with a few slides introducing our office. It's Deimel architect in German. And we're working together since 1999. So we get to the 25 years working together. The motivation for our work was to build efficient houses. And we started our first bigger project for housing with 20 units as a passive house in Berlin. And on this slide, you see the energy unit of primary energy. And we see from left to the right. So the standard of the houses improves. The part of the embedded energy this we need to construct a building becomes 50%. 50% is the use, and the other 50% is inside the building. And if you look how it's divided in different kind of uses, so you see in the blue, this is electricity. The orange color is what you need for water and heating. And again, to build up the construction, this is a maximum part. This is a slide from Switzerland, and they begin to calculate mobility to the object, to your housing unit. So we in Germany are not that far, but we have to remember that mobility is a fact that we have to count to our living footprint. And if you look for yet now inside the building, the gray part is the Rohbau. It's called, this is the construction. Yeah, this is the carrying structure. So from the 50% of the building, we need the embedded energy. Again, 50% is to the carrying structure, and the other is divided in insulation, windows, and tech. And we have a good financing for efficient building and very strict laws in Germany. And you see on top the step that goes up. This is the always getting harder law from year to year. And in the end, we are to all the European countries have to show how they will build zero energy houses. And on the other hand, there is research projects like Niedrigenergie, Nullheitsenergie, or plus energy houses. And the arrow in the middle shows that the building praxis, how the buildings are constructed, are exactly in the middle between the law and the so-called Leuchtturmprojekte. And now we have to bring down our carbon in 2020 to zero. We are in 2050, sorry. We are in 2020. And again, you can see in the middle on the red line, the Gebäudesektor, this is what building is. This is 40% of the emission. This is an enormous part. And this is what we're treating as architects or planner. And we have different labels of efficiency. And I think what you all know is on the right side, the passive house label that develops from the basic, that's called classic now, to a passive house plus and premium that you own energy on your building site, so they transform their level. On the bottom, this is KfW efficient house, and this is from the state a good financiation, and also this is you get money back to reduce your contract in the end if you had the best efficiency. This is 40 plus. So this is more or less a passive house. You have to build a ventilation system, and you have to reach all those points, marks of a passive house. And in the middle, the Minergie CH, this is Switzerland, they already had a level, this is called gray energy, graue Energie. So if you kept the minimum level of 50 kilowatt per square meter a year, you get a best financiation if you reach this aim. And this is what we focusing on now in our work. We come from the passive house planning system. This is passive house Bojenstraße, and we won in 2014 the Passive House Award with this. And it was always a mixture between concrete and wood. We're working with wooden construction since 2010 almost. And the next level is the first plus energy house we created. This is Baugruppe, we call it in Germany. This is a private investors that start organizing the building process for themselves. And plus energy, in this case, means we had to put solar panels in the facade. This was the first time we did it. And it also is a wooden construction, what was not really easy because of the fire protection of the solar panel in the wooden facade. You also see this is prefabricated wooden panels filled with cellulose fixed to a concrete construction. So we start coming to the project Weißensee. This is a map showing Berlin in the bottom. This is the center. And we have those rings of railway, S-Bahn it's called. And it's outside, but shows the development, how living develops in the city. Berlin is growing the last year, 30,000 inhabitants per year. This is a little German town every year. So the space for living to find construction areas gets smaller and smaller. And the investor found an old Jewish cemetery that is not longer used. He bought it and get the permission to build there. It was a competition with 10 invited offices, and we were the only one to suggest the wooden construction. So we get the contract to build it. And this is mostly the end of the urban development. We built 5 houses. They are between 4 and 5 stories. And 4 of them are for cooperative, and the other one is, how it's called, so self-owned Eigentumswohnungen. And we built two yards. The first one on the left, this is an open space with communal services on, and the right one is a green area with playground for children, and it's connected to the rest of the Jewish cemetery. It's a green area. So these are 2 slides for the facts. How big is it? What is the basic numbers? So we built 12,000 square meters area of use, and it's a mixture between living and open services. This is the kVW level we reached. And the price is almost interesting. This is 2,090 euro per square meter, and in total of 24 million euros. And this is the slide for urban density. We suggest to make the houses for up to 5 stories, but this is half of the area is covered with building. This is a GR set 046. And the whole plot is 2 times covered with Geschossfläche, living area. And this is the condition, what the gain or the minimize the zero emission by the standard kVW40. So this is apart from the competition we have on the first area. This is what we should build. So the maximum of floor area. And we show the idea, it was almost a third social housing, a third rentable housing, on self-owned housing. And the next shows the idea to for the urban form to create these 2 public spaces between. And on the slide, the fourth is the public services, how they are located in this little area. And we put them on the front. This is the most public area where the urban spaces, and so deeper we go into, so more privacy we have. There's some special features from living. We call it cluster. So this is like minimum apartments together in one flat, and it's for refugees, for example, from Syria. So we have 2 units with refugees. This is young people coming back from trucks and have living together with a social worker and so on. And again, the yellow are the areas where there is social services. We build a pool, a little bars. There's a kindergarten, and the other house has a restaurant. So there is a cooking, mostly a public cooking for all the people that live in this area. The idea is to have a communal living in all kind of living conditions. You are rich, so this is your own flat, and you are depending on social money, so you go to a social housing. This is the plot from the landscaper. Unfortunately, we had a lot of area to cover for the fire services. They have to get onto the windows. But the public space with all the services, should be the meeting point, and so deeper we go into, so greener it gets. This is the mostly finished, and you can see the organizing of the single housing, and they are on some places they're very narrow, and this is what we really decided to do. So if you have areas where it's very narrow, so you meet each other. That's the concept. Yeah? A lot of people building community when they met, and so you go through and get into the open space. So there are 2 slides that show the public area around. This is the playground with the view in the cemetery. This is how you see it from the existing Jewish cemetery into the area. This is the public, also services with rubbish and cycling places for bicycles. And we built 2 garages for car and 1 garage for bicycle, and they have their own lift. This is the one you see in the background. This is a lift only for bicycles to go under and put your bicycle in the bicycle garage. And this is the one view from the street, the ownership. So I declared the different system of housing, and we have to have fulfill the task to show the different types of living into one floor. And on top, you see this is those cluster units. These are small units. They have their own bathroom and they have the possibility to get a little kitchen inside. But they have a common space to use for living and cooking. And there's also possibility for service unit connected. So the social workers have even an office, or they can sleep there, whatever the service they need. And under this is mostly on the same plot, a big 5-room rentable area. And so we decided, because this was the task from the competition, to make construction like a skeleton. And so we have different axes. The one is in the facade. This is very narrow. This is 2.80 meters. And the one inside the house, this is following the line of the staircase. It's double. This is 5.60. So the decision to make a skeleton comes from the order to show inside the same construction those different types of living. This shows the basement of the floor plan of the biggest house, and the black lines is the concrete part of the house, and the green is the wooden. And if you see it in section, it becomes more clear. This is the garage for cars and private storage, and the staircase in concrete is in the middle, and on the staircase the massive timber ceilings are connected. And we have those 3 section types. The one on the left, this is a normal basement and how the construction develops up to 5 stories. And the one is in the middle, there's a step back in the ground floor. And we planned almost all areas with public services in this way. So they step back, they get a special position inside the little quarter, and we colored it in red. And the idea is if I go to the area, I can recognize very quickly where are those meeting points, where are those public areas, like restaurants, schwimmbad, and there are some little storage, bicycle repairing us stuff. And the right one section is, for example, in the kindergarten, and this is because of fire protection. This is public services, and we don't want to discuss fire protection in the kindergarten, so there was no discussion doing it in concrete. So I brought you some details to declare again the basic construction. So we see the facade panel. This is again filled with cellulose and insulation on top and get plastered on the outside. And inside there is a little fire protection, so we had to reach 30 minutes on the facade. So there's insulation, mineral wool, and gypsum. And the next level is the massive timber construction, the ceiling, and there's a beam going under the ceiling and the posts under the part of the skeleton. This is again the detail on the step back idea from the facade. Basically, it's located on top of the ceilings, and in the red stepping back construction, it becomes part of the construction and carrying structures inside the vault. And normally it's outside, it's visible in the room. This is a detail how the construction fits to the basement. There's no insulation in the cellar, so we have to create the insulation under the ceiling to get the basement warm from there. What is very I like in doing wood constructions, there's no question of cold bridge. If you combine carrion structure and you separate it from the insulation, you can see it on the left side. There is no cold bridge. This is very easily to reach all those numbers you have to reach. And again, this is the detail from the normal to the step back facade. And we looked for how much we need for this 10 centimeter insulation, again, to get no cold bridge in this part of the building. It shows like the development is the concrete staircase in the middle, then the carrying wall from ceilings and Stützen. This is like posts, yeah. And on the front, the facade is only the protection for weather. It had no carrying function. And because we discussed in Germany getting more better financing for sustainable material, we started how is how many of the construction is made in concrete and how many is in wood, and it is 30% concrete to 70% wood in the volume we built. I was very astonished about it. I never thought that is so much part of wood. Even if we do the swimming pool in concrete, we have 2 garages for parking. This is a German slide, so you cannot translate it so much. But we looked for different projects in Germany, and we have different countries inside Germany. They give a fee if you have reached a certain part of wood inside your construction. And if it would have been built in Munich, so 20% of the whole amount of the project would have get a financiation in case if it would be built in Munich that time. So, but we are in Berlin. Berlin is poor. There's no money. I show you pictures from the building side to understand the construction, how it's developed, to build up. So you see the basement is the facade in the basic construction, and the carpenters just bringing out the wooden ceiling elements. In some cases, we have steelless beams because the wooden beams would be too big in size. This is the normal way how the construction will look like. This shows the end of the basic construction. So everything you see in mass timber, this will be visible in the end, and only the facade. This is OSB will be covered. Building in wood makes you have very, very clear building sites. There is no rubbish, no waste, and even what will be the carpenters took and put it to their oven in the night. And you see the staircase in concrete and the different steps of the raster, the facade one. This is the more narrow and the wider one in the middle. So sometimes I thought that this was the best situation in the building, but we have to create flats, and it's not like a fabric or a big office. So the only rooms get to constructed in this gypsum. This is to connect the wooden beam to the staircase. And if you, to get the cairn structure through the beam, there's a steelness construction to get the weight from the top to the steel under, because you cannot give horizontal, the wood is carrying not in the horizontal way, only in the vertical way. This is from the company, how the pre-construction works. This is the finished element. We put the windows inside the prefabricated element. And so it very quickly goes to get the building closed and to have a dry building. There's no water, and we don't need to have any drying work after finishing the construction. So these are 5 buildings, and they built like in a circle. And the one start is just finished on the right side. And you see the A1 with the pool and the little B type, and how the work is going. They build out the construction, put on the ceiling, and the next level of elevation in concrete is built up. What happens now? So altogether, with the pool and the restaurant and everything, we need 2 years to build this 5 houses. This is the finish before it gets plastered. We call it a Richtfest. And we start to build out now, to put in the apartments. This is gypsum construction. It's not, we have to find a better solution than using gypsum. But it goes very quickly, and the quality is very good for noise reduction and everything. This is insulation. It's too long term to talk about this. And again, the drawing 2 types of flats and the different construction levels and axes. And we come to the finished building, showing some pictures from flats and staircase and the pool. So you see all the massive wooden construction is visible in the end, and only the white one is the gypsum in the facade that we need for fire protection. So we had a developer, we had a lot of visitors on the building site, and the developer said, why we don't have more wood visible? we need it, so we get better price. And we said, we put the wood visible where it makes sense to, because this is a carrying structure. The clients could choose to lighten it up and give it a white color. So those clients just want to see the beams and the columns. And there's a minimum cost given for us to create this project. And the one idea is to put a staircase in the middle, in the center of all those houses. And in some cases, we have 8 flats going from one staircase. And the left one this is the staircase in the apartment house, and the right one, this is for the communal social housing. So it's very rough, just in concrete. And those green areas under the there is a ventilation system. We do not put it in the flats, we put it outside in the staircase, so it's more public. It's simpler to do all the services there to be done on the ventilation system. This is the pool, the first pool we built. So it was very hard, but it makes fun. We're looking for the next one to do. And this is really public. All the people that are part of the cooperatives that rent a flat can go swim there. And by day, it's for kindergarten and school children. And there's also training for handicapped people. And the free time, it's for the inhabitants to use. So it's 15 meters and I think 8 meters in depth. This is the finishing project. So we have this narrow area going from the public to the green space. So you see those red areas I talked about. So the one at front, this is the living area for all those social housing clusters. So we mark them like this, and you saw this is their living room. And sure, it's a question of design to give the special visibility.
Thanks for the presentation. Very interesting. It's good to see mass timber construction. We have a couple of questions regarding the cost. I think that was a little bit confusing. So could you state the construction cost?
Yeah, the number is €2,090.
Okay, so the 2,000, of course, is per square foot. So that translates in 200 per square feet, and probably 160, whatever the conversion is, for dollar per square foot, roughly.
So that includes everything from the building. There's no honorar or something. It's just the degree from the construction to the green area. All those costs are included there.
Included, and also included your the architect's fee and
no, that's not.
So the construction costs, including the work on this the landscaping, let's say.
Yeah.
Okay. It's a pretty good price.
Mm.
There was another question regarding the concrete staircase. I assume that's because of fire protection. Is it also is there any thinking about thermal mass? Is that part of the concept to have that concrete core be part of the thermal mass?
It definitely will be, and we did the same construction in a single family house. So there was a concrete staircase, and the construction is the same like in these big apartment houses. There's no calculation. It's just we have to have thermal mass. So like on top of those wooden ceiling, there's a common cemetery estrich. I don't know how it's called. Yeah. So there should be thermal mass in wooden construction, sure.
And then what was the percentage between timber and concrete again? It's different for each building, right? But it was kind of
30 is the concrete part and 70% is the wooden part.
Okay, for the entire building.
Yeah, in volumes. Yeah.
In volume. Very good. Buck, do you see any question you would like to?
I see, yes, thank you, Andreas. I see a question regarding, there was a decision to use light gauge steel studs in the interior. Was it contemplated to use, to frame those in wood, or was steel chosen for a particular purpose?
It's because we have a ventilation system to get those passive house level. And so we would not have enough height under a wooden beam. So we decided to do it in steel. That's all.
For the vertical walls could be taller as a light gauge steel stud wall as opposed to a wood wall.
In the wall, there is no.
I think he's talking about the interior partition walls. Some of them.
This is this. Okay, wasn't.
Yeah, sorry.
This is a question of money. Just it's cheaper to do it.
Okay, that can be an issue. Yes, money.
Yeah, it is.
Christoph, do you know what the comparison is if you would build it in all concrete, the building, but still passive house? Do you have a cost comparison to that? With
there was one question, because the situation when we go to get the companies engaged, the costs are getting very high. There was a time where people say you cannot buy concrete in Berlin. Nobody has it now. It's sold out. And so we get the job to check what it would be cost to do all the construction in concrete. And this is just the minimum costs more than the wooden house is. It was very less. And what I think we always have to mention, if you start designing or thinking about a project, you have to do the decision what kind of material you want. We sometimes get question, people show us a finished planning and they ask, so what would it cost in wood or in concrete? And we said, no, this is a concrete building you designed. It makes no sense calculate this in wood. So you have to start constructing in wood in the beginning. And there is not such a big difference in costs in the end.
Is there, there's a question here regarding acoustics. Were there any steps that had to be taken at the floors regarding impact noise or sound transmission with the wood floor structure, the mass timber floors?
Yeah, maybe I show the detail, so I can declare it The mass timber is 24 centimeters, and we have a centimeter, 10 centimeter. This is like little stone we put on to get more weight on the construction. This is for noise reducing. And on top, this is a common noise insulation, concrete, and the wooden floor. So this is the how you have to construct it for noise reduction.
Mm-hmm.
It's the highest level we built it's possible to build. And it was checked in the end and we reached it.
Were sprinklers required? Is there a sprinkler
No.
system? No?
No.
Was there a threshold? Were you underneath a threshold that would have required them? Like what's the kind of the point at which you might have been required to use sprinkler system? Like in terms of height of the building, maybe, or area.
Yeah, the permissions define. We have 3 levels of height. Yeah, and we are in a level 4, and the tallest one for wood is level 5. And in the level 4, the carrying structure has to stay for 60 minutes for fire protection. And we calculated in German it's Abbrand. So there is a given more wooden construction that could take fire, and it's 4 centimeters in our construction. Mm-hmm. Every visible part of wood is 4 centimeters thicker, then it just had to be for carrying. And this is the fire protection. There's no sprinkler necessary. Sure, because of the concrete staircase. Yeah.
Is there a limitation in height? Can you go 100 feet, 100 stories with mass timber in Germany, or?
Yeah, it's possible now, and we have a competition finished in last month for wooden skyscrapers, high-rise building, and. So we cannot operate with 60 minutes. So all construction needs to be covered for 90 minutes, and it's possible, yeah.
Mm-hmm. And that
the wood is not visible in this case.
Mm-hmm.
Surely not. Yeah.
Is that a new law in Berlin, or was it always possible?
There is no new law. They have to ask the exhibitions from the law, but mm-hmm. It's possible. We have a big area in the former Flughafen Tegel, and they want to have it as timber houses. So there is open mind for wooden houses.
Mm-hmm. So the city itself supports it, or also requests timber structures. I see.
Yeah.
There was a question regarding the stair. Was the stair is it a single stairway, or is it actually a scissor stair there in the center? 2 stairs that are interlocked there in the center of the building?
There's a single stairway between every story. It's only one stair.
So one means of egress is required, just a single means of egress for that.
I understand clearly, single means.
So your egress means you need only one staircase for that building? Yeah. Interesting, because in New York you would need 2 staircases for such a building.
For 5-story building.
Yeah, that depends on not just the stories, but also how many apartments you have and the size of each floor.
So there is we have some staircase too. That is for the fire protection, because we have no possibility to get the window as the second escape way. And they can be pumped up with air mm-hmm. to get more security. This is a security staircase. Mm-hmm. It's expensive, but it was not possible to do it another way.
There was a question regarding thermal mass. Do you have any comparison or experience with how the building behaves as a passive house? Mass timber compared to a more concrete and more mass in the building? Does it behave differently, or? in your experience?
Unfortunately, I have no flat in, so I could test it by myself. There was a question from one of the inhabitants, and they asked me, why is it too warm in winter?
Mm-hmm.
Yeah, they have 23 degrees, and people think it's too warm for them. So this gives me the information it works as a passive house. Because if you use this kind of insulation in a multi-storied house, it normally is too warm.
Mm-hmm.
So you get very less days you come to the 20 degrees inside.
Do you require supplemental heating, or is the sun enough with your building envelope?
Yeah, we use the system. There is a heat recovery in the ventilation system, and we get about 85% back from the inner heat after the heat exchanger. And we have a little radiation in the rooms, very small one, to get it warm inside. So there is a heating, active heating, and the ventilation system, both of it.
And what's powering that active heating system?
There is a power station, heat from the power station.
It's okay. It's like
Fernwärme.
It's a common to the community. There's a
yeah.
Understood.
Similar to the steam, but it works with water in Berlin.
Do you have so the facade? If I understand correctly, those are panelized elements.
Yeah.
And the structure itself is also kind of a mass timber, or is that like a framed?
No, it's like a framed.
A framed wall.
Yeah, and inside is cellulose.
And then you render a plaster on the outside, so you have like a wood fiberboard, or what do you use as a substrate for your plaster?
The top is a wooden insulation, and it's fixed on the prefabricate.
Which company does the
many
plaster?
The plaster?
Yeah, the system. I mean, the system itself.
The wooden panel is Steico or Knauf or
okay.
something, yeah. And the plaster on top is just a normal plaster company.
Mm-hmm.
They can do it on wood panels now. In the beginning, they did not like it to do it on wood. Mm-hmm. It's getting very common now. Mm-hmm. And it's again cheaper as a cladding in wood. It costs a very lot. Mm-hmm. So the plastering is the simplest way to do it. But it's not sustainable in the end. Because we think about we have to put the buildings back. We get the material back into the material circle, and such a plastered insulation panel is rubbish. You cannot bring it back to the material. You just can burn it in the end.
So I guess that's the most economical system, though. That's in terms of, from a financial standpoint, that plaster is the most economical solution, because otherwise you'd need to put a rain screen type system that might be demountable or reusable.
Yeah, yes. Yeah. But I myself cannot imagine a city full of wooden cladded houses. So I like the plaster facades, but this is not the end of solution. It should be mountable, put away without producing rubbish. So we're thinking about how can we do it.
That's excellent. Appreciate hearing that you're thinking about all those matters.
I mean, the plastered wall in Berlin is very common, right? So that's a common appearance of a building. Have you thought about is it possible to give the wall a profile, so to speak, so it looks more like
a Gründerzeit-house?
For example, yeah. If you build in a neighborhood, where you have historic neighborhood where you have to treat your wall differently, is that something you can do with the with fireboards? Have you thought about it?
You can do it. We just designing a project, and the four walls, the two of them are cladded with wood, and the other two are plastered. And you cannot put a wooden cladding in the same dimension as a plastering cladding. So you have a step back from the wooden part to the plaster. Mm-hmm. And so we decided to do some, so to get a step back in the wooden, in the plastered area. So we put more insulation on the wall to get that step back than we would need. Mm-hmm. So just an aesthetic argument to do it, and you can do this.
There was one question that just came in about what is the vapor profile of the exterior wall? Is it completely vapor open? Is the building under positive or negative pressure?
Yeah, the construction is vapor open, and we can do it by a mineral plaster system. And it's not on, and the OSB plate in the middle is also open, and this guarantees the long term of the construction. And so you can get water in and even out. And if the building is under pressure, no, we tested with a blower door, like all passive houses. This is what we did, but there's no special pressure inside.
It's like a effectively pressure neutral. It's not pressure.
Yeah.
Okay.
Yeah.
And I assume that the panels, the OSB sheeting is your airtight layer, correct? I guess.
Yeah.
And is that taped with a special tape? And then how do you connect each panel to make them airtight?
There are no more tapes. They make the make it between the beam and the panel. This is like silicone, mm-hmm. what they put on. So it goes very, very quickly, and this is finished if it comes to the building site. So there is no taping in the area. They don't need it anymore.
Mm-hmm. How large are the panels?
Now, how they can carry it on a truck. So this is 3 meter height and up to 15 in the length.
Mm-hmm. So they're large. Uh-huh.
Yeah.
So the joint is it's not a caulk. It's like you have a gasket, a continuous gasket that is where the panels meet.
Gasket, I don't understand.
Yeah, like a joint where you join the panels together. It's a silicone, I guess.
Yeah, something like this. Yeah.
Do you do it with a tube on site, or is there a gasket, like a material that you roll out that is compressed like neoprene?
It's comes from the tube, and is this ready if the element is ready? It's prefabricated. The airtight area is also ready.
So that's filled up like that the caulk where you join the panels. Interesting.
Yeah.
But I didn't see that joint on the outside in the plasters, or is that it's just in the picture not visible?
No, the airtight area is inside, so there is nothing to be seen.
Oh, so the plaster is rendered later on.
Yeah.
Oh, I see. Okay.
It's not on. Yeah. Mm-hmm.
So there's one more question. Probably we'll take one more. It's also related to overheating of the building, and because it seems like there's no shading provided. Is there any shading in the building? Do you have like shutters or something?
Yeah, we have to calculate it. It's mm-hmm. part of the permission planning, and this is very very detailed. There's a room that needs shading, and the neighbor room does not need, so there is no shading. It's just always looking on the costs. And for every room, it was calculated.
Uh-huh. And so
there even is some sun protection glass in,
mm-hmm.
because it's even cheaper than to a shading system.
Mm-hmm. And if there is a shading system, is that integrated into the facade on the exterior, or?
Yeah, it's on top of the window, and this panel is. Yeah.
rolled on
in front of the window. Yeah. Mm.
No, I really delightful to hear about this project. Very impressive, and thank you for presenting for us here.
Yeah.
So yeah, thank you everyone for joining us today, and thanks Christoph for presenting that fantastic.
Thank you for the invitation to New York again.
Definitely, yeah, you are welcome.
Maybe we do it in real sometime.
Absolutely, yeah, once it's possible again. Thank you so much, everyone.
Okay.